A conservative force. A small block with mass 0.04 kilograms is moving in the xy plane. The net force on the block is described by the potential energy function u of x and y, 5.8 x squared minus 3.6 y cubed. What are the magnitude and direction of the acceleration of the block when it is at the point x equals 0.3 meters, y equals 0.6 meters? So since F is a conservative force, it's derivable from a potential energy function, we can write the force F is minus the gradient of the potential energy function. The gradient operator applied on the potential energy function gives us minus partial derivative of potential energy function with respect to x I hat minus the partial derivative of potential energy with respect to y j hat and partial derivative of the potential energy with respect to z k hat. Okay, so this will give us, because we have the potential energy function 5.8 x squared, the derivative with respect to x gives us 2x, so it's going to be minus 2 times 5.8 x I hat. The derivative with respect to y for y cubed will give us 3y squared, so it's going to be minus 3 times 3.6 y squared j hat, and there is no z dependence here, so that will give us 0. Therefore, we find that the force is 2 times 5.8 minus 11.6 x I hat, 3 times 3.6 minus 10.8 y squared j hat. So now we're ready to evaluate the force, that's the net force acting on the block, at x equals 0.3 meters and y equals 0.6 meters. This will give us minus 11.6 times x, which is 0.3 I hat, minus 10.8 y squared 0.6 square j hat. So this gives us minus 3.48 I hat minus 3.888 j hat. And since the net force acting on this block is equal to F, it must be equal to mass of the block times the acceleration acting on it. So this is 0.04 kilograms times the acceleration of the block. All right, so the acceleration becomes minus 3.48 divided by 0.04 minus 3.48 divided by 0.04 I hat minus 3.888 divided by 0.04 j hat, and this becomes minus 87 I hat minus 97.2 j hat in meters per second square. We're using SI units. Therefore, what is the magnitude of the acceleration? it is square root x component square 87 square plus y component square 97.2 square. So this gives us, because everything is given in 3 significant figures here, that's the minimum number of significant figures in this problem. This gives us 130 meters per second square up to 3, rounded up to 3 significant figures. Okay, and what is the angle it makes with the x-axis? Tangent theta is ay divided by ax, which is minus 97.2 divided by minus 87. So this gives us an angle of 48.2 degrees or 228 degrees. Now, which angle is the right angle? So I look at the possibilities. This is a y-axis, this is a x-axis, first quadrant, second quadrant, third quadrant, and fourth quadrant. Now I have ax negative and ay negative, therefore I'm in the third quadrant. So since ax and ay are negative, the answer I should take is theta is equal to 228 degrees. So what does that mean? So this is the positive direction for theta here. So this angle is somewhere here. 228 degrees. This is measured counterclockwise from positive x-axis. Or I can say that theta is equal to 360 minus 228, 130 degrees, measured clockwise from positive x-axis. So these are two equivalent answers. All right. So this is an application of a conservative force. A conservative force means it's derivable from a potential energy function. It's minus gradient of the potential energy function, so that the work done by such a conservative force is minus the change in the potential energy, work potential energy theorem. So the other thing is, because it's equal to minus the change in the potential energy, work done is independent of the path taken for this force. So that's another way to say it. So given a potential energy function that represents this force, force is equal to minus the gradient of the potential energy function minus partial derivative with respect to xi hat minus partial derivative with respect to yj hat minus partial derivative with respect to ck hat applied to the potential energy function. That's the operator. So that's what we do here. We take the derivative with respect to x, derivative with respect to y, and multiply it by I hat and j hat. So this gives us the force. If we evaluate the force at x equals 0.3 and 0.6 meters, we get the force vector at that point. So this is measured in newtons. We're using SI units here. Now, since this is the net force acting on the block, net force equals mass times acceleration, Newton's second law. So by dividing the force by mass, I obtain the acceleration vector. And I'm asked to find the magnitude and direction of the acceleration. Magnitude is square root of ax squared plus ay squared. The tangent of the angle it makes with respect to the positive x-axis in the counterclockwise direction is ay over ax. And now I obtained several possible answers for tangent theta, actually, because we can see that AX and AY values are negative, so I have to be in the third quadrant. The answer I should take is not this one, but it is this one, 228 degrees, measured counterclockwise, or I can go clockwise, 132 degrees, and I would find my acceleration vector.